Hello everyone, I'm Brian from Watch Complications. This is another video in the Making Custom Watch Dials series, and you might notice my environment's a little bit different. That's because I also have a workstation set up in my basement for my pad printer and for painting and messing with inks and all that wonderful stuff, which is sort of away from everything and everyone else. It's away from my main workstation, which is in a nice comfier spot upstairs. Today I want to walk you through the setup for doing pad printing and some of the things you'd want to know, think about, or be able to have created or make yourself if you wanted to get into making custom watch dials. And so I'm going to walk you through all of that, show you how the setup is all done with the pad printer, with the fixtures, with the plates and inks. And then in the next video I'll show you me using all of these things then to make a custom dial for an actual customer. So let me give you a tour of the different components that you would need to make a really nice, high quality custom dial. So I want to talk about the plates first. If you're going to make a custom dial and do printing on it, that is printing high quality numerals or markers, that sort of thing, then there are a few ways you can go about that. Of course, markers could be applied, they could be printed. And in this case, we're going to talk about printing. Now, here I have a blank plate, here I have a plate that has some etchings on it. So let me talk about the concept first, and I'll use my logo as an example. So here I have on this end of the plate my logo etched for my brand, which is 10.6, and you can see it is quite small. It's also quite detailed. That's because this is etched with a laser. Now here's the concept. So the process works something like this. I have a plate, which is a flat surface. A laser will etch out the design that I have. So these are really holes. You might think of it as hole or troughs in which things could go into, particularly ink. So ink will go into the gaps, the white you can see on this particular plate, and fill those evenly with the surface. And then a pad will press down on this, pick up the ink, and then will transfer it to the surface of the dial. That's the concept, okay? And you can look up and read about the pad printing process, but that's the general idea, okay? So these are really high detailed etchings that are done with a laser. There are two ways to generally do this. One is sort of photosensitive. Well, really there's three ways. There's acid, there's photo, and there's laser. And older dials back in the day were done with acid etching. This is done with more modern technique, which is laser. If you're going to do this yourself, a lower cost way to get into it would be photo etching, in which case you print out a design on your regular old home inkjet printer, and then you've got to go through this process of placing it over the plate, exposing it to UV light, washing it away, cleaning it. It's a really involved process. If you were able to have access to a laser that could just cut directly into steel plates, then you're going to save yourself a lot of time and headache and those sort of things. But you can come up with a reasonable design if you're doing this with a photo etching, but I have a local manufacturer who's fairly close to me who has a laser that can do these etchings for me for relatively low cost, and so that's the route I've gone. Is I have cliches, which are these steel plates. You can get them in different materials, different thicknesses, etc., and I just get the plates and then they get etched with a laser. So they are basically perfect at whatever size you want to create this particular vector image. And again, this is quite tiny, but you can see my logo is quite detailed at a very small size. They can go on the dial at, say, 12 o'clock or wherever I want to put it on the dial. Now, some of the different designs, these are projects that I'm working on. Of course, that's my logo. This is a different project I'm working on. This is off-centered a little bit, so this is getting redone. So you can see another example here. This is for a GMT project. I've got the hour and minute markers. I've got numerals for some of the hours, some initials for the person's name, and you can see the other numerals here for the GMT. It mentions it's a GMT. I've got a border for the date window. But if you were going to do a single collar, you would want everything on the same etching. So if this was all going to be printed in, let's say, white, which is going to be the case with this example, if everything's in one color, you can do one single etching. But if you're going to do different colors, then you have to do multiple etchings. Every color would be a different etching. So the logo I have separate so I can do it in whatever color I want, no matter what the dial face is. This is going to be one particular color, so this is part of the same dial. This is going to be one particular color, and then the other color is going to be sort of a blue. This will be black, and this will be blue, so the rest of the numerals. So if you have multiple colors, they have to be different etchings. And then here I actually have an etching for just the entire dial surface. That way, if I want to print the entire surface a base color, this will get filled with ink. The pad will come down on it, pick up the entire thing, and transfer it to whatever surface I'm printing the base color on. So just a couple examples of plates that have been etched, in this case with a laser, so that I can use my pad printer with them. So the next thing I want to talk about is ink, which will go into the etchings and be transferred from the etching to the surface of the dial. And there are a lot of different types of inks out there. I'm currently experimenting mostly with multi-purpose inks because they seem to adhere quite well no matter what sort of surface I'm printing on. Obviously multi-purpose ink. But there are like UV inks that cure in light or when exposed to UV light, and you can choose and look around a lot. There's lots of different options, lots of different colors. You've got to mix your own colors usually. This is just a black ink. So what the process is sort of like is I have just a concentrated black ink here, and what I'll do is I will take a certain amount of this ink and put it in a cup of some sort. I have a micro scale here for grams. Let me just show you a little bit of what this looks like. So it's a micro scale for grams, and I can put my cup on this, right? And I can zero it out, just make sure it's at 0. I'll put a certain amount of ink into the cup, okay? And then I'll put a certain amount of thinner, this is a paint thinner, into there. Usually it's like a 10:1, 8:1 ratio, something like that. It depends on the type of ink. There's so many different types of inks. This is something you have to test in your environment based on the temperature. It's extremely tedious, but once you get it right, you'll notice because the pad will pick up the ink without any problem, transfer it without any problem. It's just finding that right mixture of paint to thinner so that it's got the right viscosity to be picked up by the silicone pad and transferred to the dial. But basically, you measure out the different parts of the ink. Again, if you wanted different colors, there's different colors of inks, but if you want, something that is a particular shade, like one I'm working on right now is a particular shade of green, you got to have the right amounts of red, green, blue. You have those colors in your arsenal. You can mix the right components at the right ratios and get the right color or tint. You add the thinner, and then you've got the right viscosity, and you can use that particular ink to print. So you've got to be pretty careful about how you measure and interact with the inks. And that's just one of the things that, is part of the process. Getting the ink right just takes practice. It just takes testing to get it right. So let's go back to the process a little bit. And so I have a pad printer, and this particular device called an inkwell is going to be attached to the pad printer. It's basically an empty cup that holds ink in it, and these are magnets, by the way. So this is very, very magnetic. It will basically seal this to the surface of the plate. So imagine ink inside of here. This will be adhered to the plate. You can hear it sort of attach. This will be filled with some particular color of ink. This unscrews at the top, so you can fill it with ink. You can see the image in there. Let's say I take the ink and I pour it in here, and then I'll seal that up just so it doesn't dry out. The pad printer is going to wipe this thing across the surface, fill that location with ink, and then the silicone pad is going to drop down on top of that etching, pick up the ink, so the ink will be adhered to the top of this surface, and then this will go to the dial, press down the dial, and transfer the ink over. That's the general idea of the process. And the way that the ink is transferred from the etching to the dial is with a silicone pad. And there are different sizes of these depending on what type of dial or surface you're printing on. I've got different varieties for different sizes. And again, these are soft, but fairly firm to the touch. This is about 2 inches in terms of the American standard system. The watch world is mostly measured in millimeters, and so it's really just a matter of figuring out, okay, what's the surface area of the dial and what pad might work best. And right now I'm using this pad for several of my larger dials just because it's got the surface area. You can see I'm zoomed in on my pad printer right here, but let me pull this back just a little bit so you can get an idea of the actual machine. These are varying in cost, location you get them. I ended up getting mine from eBay at some point. They can be, again, sort of all over the place in terms of cost. This is not a particularly high-end one, but it gets the job done, and it's of Chinese manufacturer. And it's got enough different components and moving parts and replaceable parts that I can sort of make sense of it, and I can update it or change something about it, move things around if I want. So I'll walk you through the usage of this machine through this video series. So let me show you how this thing is used. We have a steel plate here. This is actually quite heavy. This is the surface that the plate sits on. So those blue plates we were just looking at will sit on top of here, and there's a notch here for a hole to go through and keep it secure, and then the other ends will have screws, again, to keep this in place so it doesn't move. This will sit inside of here like so. Okay, so that sits in there. Again, I keep it flush toward this corner over here. That's just how I've got my setup done. There are screws back here that can tighten to keep that nice and secure on the surface of the pad printer. So one thing is the surface for the plate. Again, I can have a plate which I can put on here that has etchings on it, and it will sit on this surface like so. Now, the next thing is the thing that holds what's called the ink cup. So here's a part of the pad printer that will, again, bolt to this back part of the pad printer. There's a couple screws on the back that will hold this little holder in place. And what sits inside of that is the ink cup, which I just showed you. So here's the ink well. We'll put ink inside of this, but in order to put it on the surface, we'll put it around like so. You can see that that is highly magnetic, and this will attach to the back of this device. And then I can unscrew this and put the ink in, that sort of thing. Okay, so we have the plate surface. We have the ink well, which holds the ink, which is, again, whether it's pressure or magnetism, something is holding this very tightly to the surface, and ink is inside of here. We've got the pad, the silicone pad up here, and again, everything on this machine is sort of replaceable or removable or movable. So here I'm going to take the pad off of here. This is similar to the other pad I just had, except it has the holder on it. So I've got a couple of these. This one has the connector on it, so I can unscrew this and put it on this pad and change the pad I'm using. You can see I've drilled holes at the appropriate locations for holding this pad. That's one example. Let me show you another. Here's again a different pad for different types of surfaces. All you gotta do is put the holder on top of the surface. This is just wood, and the silicone is wrapped around it, adhered to it, basically glued to it, and drill the holes in the right location, attach that, and then you can put it in the printer depending on which silicone pad you want to use. So let me attach this back to it to walk you through the example. So we have the plate, we have the ink, we have the pad, and then we have what's commonly called a fixture. Again, these I get custom made locally here for me, and this is a piece of acrylic. So this is plastic, which again has been laser etched. You can see there are circle cutouts here, and I've had this done on the four corners so I can put the bolts to hold this thing in place on whichever corners I want, given my setup for this particular printing. This is a piece of plastic. It's basically the same width as the surface for the plate. And so again, one of the things about this pad printer is I can move this forward and backward, left to right, up and down. It's got all the different, you see all these knobs. Basically, you can lock it and turn it in basically any direction so that you can get it centered in whichever way you want and held in place however whichever way you want. Now, I've mentioned in some of the earlier videos in this series I use my 3D printer often to print dial blanks. And so these make great test dials. So I'll print a bunch of test dial blanks off for a particular project I'm working on, and then I will use these on here so that I can get this centered. I will do lots of test prints so that I can make sure that this is all set the exact place I want it, so that when I put the actual dial blank in that I want to print for the final product, I can have everything perfectly centered. So my 3D prints often become just blanks that I use for testing to get this whole setup centered for a particular dial. After I've changed inks or I've switched the plates around from one side to the other, you've got to basically go through the same series of setup to make sure everything is centered so that whenever you press it down, it is exactly where you want it. And really cheap for me to print off, you know, dozen of these and have these test blanks ready to use for getting this thing centered anytime I want to print a new dial. So what this fixture is, again, is a piece of acrylic that's just basically been laser cut to the exact dimensions that I want. Again, there's the holes in the corners for holding the thing in place against the pad printer, but then you can see here is a center location. That's where the center hole is on the dial, and you can see I've got dial feet locations in this fixture. That's so I can take a dial for a given size, and this will sit down inside of those holes flat, and there's just enough friction. Those are cut with a laser, so they're exactly the size I want to match the dial feet. And so this will sit in here, and even though I'm putting a silicone pad on it, it's not going to pull it out of here. There's enough friction to keep this thing in place. This is up to 38 millimeter on this particular fixture, and this will hold dials that are in sort of your typical ETA or Soletta, 2800 series, very common dial feet locations for a lot of Swiss, both mechanical and quartz movements. And whether it's got a date window or not doesn't matter. So there's something in the middle that's kind of holding this in place, so it's a raised surface in the center hole, and then the two holes for the dial feet. So I've got three locations that are sort of keeping this dial in place and holding it so that it doesn't move around, keeps it nice and centered. Again, to get one of these particular sort of fixtures made, you'll oftentimes see them in other videos, or if you're in a professional, watch manufacturing facility, these are going to be made of steel and usually circular. But for my pad printer, and for low cost, this was like $50 for me to get made, is this particular fixture cut with a laser out of acrylic, with the dial feet holes lasered out, the center hole. So this has basically been cut out of this piece of acrylic, so this has got some depth to it at the thickness of the dial, which is about 0.4 millimeter. So this is a 0.4 millimeter depth. This hasn't been cut away in the center, and then we've got the 0.8 millimeter dial feet locations drilled, because most dial feet are about 0.75 millimeters. So dial feet drilled, so on and so forth. That's the fixture. You got to have something that can be attached to the pad printer, stay in place, that you can tweak and move on the surface so that you can get it nice and centered. And then having lots of testing dials or testing blanks for making sure it's printing exactly where you want. Then you can put your final dial blank on it to print. So for example, I might print off a lot of these plastic dial blanks, but then the final dial blank I put in there for the actual production watch I'm making might be just a primed metal that's more sturdy and solid than a 3D printed PLA plastic. So that's the fixture. Again, the pad, the ink, and the plate. Now what happens is the plate sits on top of here that has the laser etching. This device, the pad printer, I will pull the device this way. I'll pull the lever this direction. The ink will go into the etching, Again, then I'll push it back. I don't have it connected right now, so not a big deal, but this will go back this way. The pad will come down, touch the plate, and that reserve of ink in the etched location, pick it up, I'll move it back, and then print it down on the dial surface. That is the process, okay? And again, I don't have this attached right here, so don't worry about that right now. Not a big deal. I'm just showing you generally the idea. Got to keep all these locations lubricated and stuff, but that's the process. Now, in the next video, what I'll do is I'll show you me actually doing that with one of these custom designs. Now, I know that's just an explanation to get started thinking about it in this video of the different components you would need. You need the plates, you need the pad printer, you need the silicone pads, you need the ink in an appropriate way for measuring the different colors that you would need to make any particular tint or color of ink that you would want, unless it's a solid color, but you got to start with something. You got to have a fixture that you can manipulate and get it exactly where you want, and you know, it's all these different components to actually make a high quality dial. And we haven't even talked about lume yet. So again, you could have applied markers, which you have to apply with adhesive and get them in the right location. You've got the option to print with luminous ink as well, which I'll do in the second project, which I'll also again show as part of this overall series because I'm doing one of those. But this is an overview of all the different things you'd have to think about in terms of getting started on your own with making a really high quality custom dial. And really one of the things it comes down to is having a manufacturer that you're working with to help you make the things you need, unless you have, you know, a machine shop of your own. So for example, ordering the plates, you can order the plates, but to go on the pad printer, you've got to have hole punches in the right locations for your pad printer. You've got to have a laser or photo etching to get the design etched into the plate. You've got to, again, get the viscosity and the color of the ink correct. You got to have a fixture, again, where the best way to get a fixture made is to have it machined, or in this case here I've got it lasered into acrylic. A lot cheaper, works just as well, but I couldn't do that on my own because I don't have a laser in my house. I wish I did. But I can get something like this made for relatively low cost because I've got someone local to me who can do that. And in most big cities you could probably find something like that, but if you're going to get into this, you're going to have to do a lot of digging and looking around for people that can help you in terms of sourcing the materials, sourcing the components that you would need to get into it, whether that's the plates themselves, the etching, the inks, the buying a pad printer, which isn't necessarily cheap. By the way, this one was about $300, a little less than $300, and it's really the low end of sort of a manual pad printer, but it's got all the moving parts, so I can get things made and machined and bolts off the shelf, and I can make this work for me. And if I don't want it to move, also, you can bolt it to the table. So this is just a simple setup, but it's one that works, and it works for me for making a lot of custom watches. This is just one approach to making a custom watch dial. There are a lot of ways out there. This is particularly high quality in terms of the sharpness of the image and whatnot because it's all done with a laser. Now, you could also go UV printing. I'll try to show that process at some point because I've done that before with a UV printer. But here I've got traditional pad printing with plates that are etched by a laser, again giving that high quality. In a future video I'll talk more about the different dial materials and printing on them, priming them, that sort of thing. Probably maybe in the next video when I actually show me printing on the dial. But I'm finding out in my testing that this pad printer and multi-purpose inks print really well directly on 3D printed PLA plastic. So I think I'm going to be making quite a few custom watches that have just direct pad printing with multi-purpose ink on PLA dials that I've designed. I think it's going to look really cool, really unique. So that's one thing I'm working on. But I'll also show you in the next video with an actual project printing on a typical brass blank that's been primed with a whitish gray color, and then I'll show you the finished product when it's all done. Alright, so that gives you the lay of the land, shows you the setup. What'll be more interesting probably is the next video when you'll actually get to see me using all of this to create a custom dial. I'll show you the mixing of the inks, placing the plates, using the pad printer, and you'll be able to see the final product, the final dial that's going to go into an actual customer watch. So be watching for the next video. It'll show all of that. But for now, subscribe to the channel if you haven't. Follow me on Instagram at watch_complications. And thanks for tuning in.